Alright, so now this is another part of skill 2, log properties. You want to go ahead and get these down, do them before I've done them to see if you're on the right track, alright? So we're talking about writing a log of 26 as the sum of two logs. So this would be using, this is that product property, right? So this is the product property of logarithms because the log of 26 is the same as these have to be multiplied. So log of 2 plus the log of 13, right? Because this 26 could be shown as 2 times 13. So that's where you see the product. If I take 2 times 13, that gives me the 26. Here's where you see the product, okay? So now I'm talking about finding the log of 50 by subtracting logs. This would be a quotient property. And I know it can be kind of confusing because we're talking about quotient, but you're subtracting, right? But I could show 50, okay? So let's say log of 50. Instead of calling it 50, I could call it the log of 100 divided by 2. There's your quotient. And that equals the same thing as the log of 100 minus the log of 2, right? So when they're subtracting, I can divide 100 divided by 2 to put it together, which gives me that log of 50. That's your quotient property. Now, 3 times the log of 81 in a different format. I don't remember the name of this property off the top of my head, but if I take 3 log 81, I could always flip that to there. So that's the same as the log of 81 to the third. Oh, it's the power property, right? And this is the power property. Those are the 3 log properties that we did. Those just happened super quickly. We got one more left, y'all. Yep, this is it. What? All right, now we're going to take something that you all just did in class today. All right? So you did the thing about the vampire population, and we came up, every group had no problem coming up with this equation to model the vampire population. So I want you to answer 2 questions. How many vampires did we start off with? And how many years will it take until we have 700 vampires? Okay? Go ahead and solve that. I think you're going to have to use some logs and log rules to solve it. We'll see. All right, so how many did we start with? Should be easy. We started with 10 vampires. It's my initial value, which is right here. There are 10 to begin with. But we said, well, how many years until it's 700 vampires? That means I'm here, right? Because X is my amount of years. This is my unknown, and I want to know when am I going to reach 700 total vampires. I think I can do this. So I'm going to go ahead here and divide by 10 because I want to isolate my base with my exponent. So I'm going to divide by 10, divide by 10. So 2 to the x power equals 70. And now I am going to use my calculator to figure this out. I'm going to use some logs to help me. Remember, logs get rid of this base, so I'm going to take the log base 2 of 2, so those cancel, and it leaves me with x, and I need to figure out the log base 2 of 70. My calculator doesn't work in base 2, so I have to use my change of base rule. So that equals the log base 10 of 70 divided by the log base 10 of 2. And I can put the 10 here. If I want to, I don't have to, because that's kind of just a given. All right, so let's see. Log 10 of 70. Ooh, that's not what I wanted. Just kidding. 70 log base 10. So log 10 of 70 is about 1.85. And the log 10 of 2 is 0.30. And I'm going to take 1.85 divided by 0.3. And I get approximately 6.16 repeating years. I wonder if you can see that. Now you can. 6.16 years. All right? So there it is. These are all the things that are going to be on the test. My shout-out list is bare. Nobody else has asked for shout-outs. So you know who I'm going to give a shout-out today? To math. This one goes out to math. Yo, we love you. You hexa fun, son. All right, we're out.